Hi, my name is Sebastian Majawi. This is my free demo on Learning Target 4B. Today I'll be demonstrating that I can translate between equations, truth tables, and logic circuits. In our first example, we'll be translating this truth table to an equation. The first things first is we gotta look in the rows where p equals 1 and use those values to make our conical equation. As you can see, 3 ones leads to 3 midterms. Our first example here is 0, 0, 1, 0, 0, 1. From here, I simplified using Boolean algebra rules. First, I factored out a y prime. Then I factored out an x. Z prime or z equals 1. By rule 11, x or x prime z equals x or z. Finally, to get it into standard form, we distribute the y prime to make the equation y prime x or y prime z. And in standard form, we get p equals y prime x or y prime z. Our next example here, we'll be going from an equation to a truth table. We notice our domain has 3 variables, a, b, and c. So we list them under our inputs column over here, a, b, and c. Then I break it up into segments. We have a not b, a, b, and then an a, b, or c. Then I determine their logic. Every time b equals 0, not b equals 1. For every time it equals 1, not b equals 0. Then I can stop looking at this one and simply look at a and b. The only time a, b will represent 0 is if both are 0, and the only time it equal 1 if both are 1. As you can see here, a, b are 0, we get 0, a is 1, b is 1, a, b is 1. For our next column, a, b, or c, we can ignore everything else besides the c column and the a, b column. The only time a, b, or c will represent a 0 is if both c and a, b both represent 0. Other than that, if a value contains a 1, then it will hold a 1. The only operation we have left is the OR, and this will determine our final output. We have 2 big terms being ORed, A, B, or C, with not B. The only time that the output can be false is if both not B and A, B, or C hold 0. Other than that, everything else will be true. Here we have a logic circuit, and we're going to be converting it to an equation. Over here we see we have x, y, and z. Over here we see we have an AND gate with x and not y passing through it. So we simply write x and y prime. Here we see z going through a NOT gate, and it turns into z prime. We follow these two, and we see that x, y falls into this NOR gate, falling in with the z. So then we get x, y prime, or z, and we put it in parentheses, and we negate it at the end. And our equation will simply be like that. Now we'll be converting a logic circuit into an equation. We see we have x, y, and z signals. X, y, we follow the x, it passes into an AND gate. The y follows in and passes into a negate. Now we'll be converting a logic circuit into an equation. We have 3 signals, x, y, and z. We'll follow the x into this AND gate. Y will pass into a NOT gate, and it'll turn into y prime, and there'll be x, y prime. Then we have z, it passes into a NOT gate, and it turns it into z prime. And then we have a NOR gate over here that has x, y prime, and z prime passing into it. And our final outcome is A equals x, y prime plus z prime. And then we're going to negate the inside term, just like that. And that's our final answer. Here we have a logic circuit to an equation. We see over here we have these 3 dots, and they represent where each signal is branching off to. Over here with A, we see that it runs into an OR gate and a NOR gate. And with B, it branches off into this gate over here, OR, NOR, and OR. We follow each signal. You see that we have A falling into this OR and B falling into this. We get A or B. Over here, we see that the A and B signal falls into this NOR gate, so we get A or B negated. And then C falls into this OR gate with B. After that, these 2 gates, these 2 Boolean expressions, get ANDed together to get A or B negated. Then C follows right in. B or C follows right in and gets NORed with this top expression here. So Q equals, we write out the whole equation, A plus B negated. And then it gets ORed together with this expression right here, B plus C, and then we negate the whole thing, and that's our final answer. Here we have an equation to a logic circuit, and I already constructed the logic circuit. So the first thing we need to do is determine how many gates we're possibly going to have, and let's count. We're going to have 1, 2, 3, 4, 5. We know we're going to have 3 OR gates, 1 NOT gate, and 1 AND gate. I listed our signals A, B, and C, and let's start with the first gate. So we know we have A or B, so I constructed an OR gate with A and B signal running through it. After that, I added a NOT gate with B passing into it. Then I emphasized to make sure these branches were here so I know where my signals were going. A passes into this OR gate with C. After that, I follow and I see that A or B and A or C is going to be another gate. So I create an AND gate with these terms, with this OR gate right here and this OR gate right here. Next, I follow the outline to construct our final A or B and A or C, or not B. So this term right over here and not B will follow into this OR gate that I created. And this is what we got.